So we've got Rebecca here, everyone. She is a security architect at 6.6, and today she's going to be talking about applying the MITRE ATT&CK matrix to AWS. I'm super excited about this talk, one, because I find it fascinating, and also because Rebecca was telling me that this is what she did her thesis for during her master's at the Royal Holloway. So some really good research has obviously gone into this. So I'm really excited to see the outcome and the presentation that you've got to deliver. I think it'll be great. So everyone, just keep the conversation going in the chat while you're listening. Any questions, fire them in, and we'll pose them to Rebecca afterwards, and I'll come back. But without further ado, I shall let Rebecca take the floor.
Thanks very much, Dean. Hi there. So Dean's pretty much done my first slide for me there. But as you said, I'm a security architect at an IT consultancy called 6.6. It's my job to collaborate with design teams and help them implement security requirements. In my previous job, I assisted in the design of a security operations center architecture in AWS. And as you said, this talk today I'm doing on my the topic that I did on my thesis for my master's, which is detecting MITRE ATT&CK techniques using AWS. I spent 3 months of my life doing this, so be kind, please. Okay, so what is this about? So it's essentially a demonstration of an approach that we tested at my previous company, and it was just to help our security operations center get started, get hands-on with monitoring those attacks on our new AWS environment. So it's also a bit about the MITRE ATT&CK framework itself and how we actually used it to prioritize the techniques and which real-world techniques we were going to look for. And I'm going to use walk you through one example of how we detect some of these techniques. Okay, so first of all, for those that don't know what the MITRE ATT&CK framework is, it's essentially a massive grid of different techniques that attackers in the real world use. There's a number of different matrices, I'll show you one in a minute, that cover techniques across all different environments. So they've got one for Windows, they've got one for Linux, they've got one for Mac, and they've got a few for cloud and for some other technologies. So take a Google and you can have a look at all the techniques that they list on there. It's used to, I suppose, emulate real attacks on your environment, so you can add security controls or monitoring to prevent these sorts of attacks happening on your system. So that's a horrible slide. I don't expect you to be able to see any of that. That is one example of one of the matrices, just to show you the breadth of the types of techniques and attacks that they actually cover. It's massive. So my thesis was to take these and understand what they were, and using native tools, try and see if we can stop some of these happening. I've just shown you another one there, just a bit of a smaller one. So they've got one specifically for AWS on there. So that's a new one that they released just at the end of 2019. I didn't actually use that one for my master's because it wasn't available, but it is sort of a good narrowed down, shorter list of techniques if you want to try and pick a few that are pertinent to AWS. Okay, so before we get kind of our hands dirty with actually detecting some attacks, there's 3 decisions that you need to make. So this is all part of the approach. So the first one you need to do is to choose if you were looking to apply this in your own company, then you need to make 3 decisions. The first one is what threat model you're going to use. So I've sort of already done that for you. I've picked MITRE. There are others available, and I'll come on to why we picked MITRE and why we thought that was the best one. Decision 2, so this is a security bread and butter, just to help narrow things down. For this approach, you need to pick one system that's really important to you. So it's no good just taking your entire environment and trying to detect attacks across the whole thing. It's going to be too difficult. So what we wanted to do is just pick our most important system. So I'll list some things, what you might want to help you make that decision. And then finally, decision 3, we need to break down that matrix. So we need to narrow it down, pick the ones that we think are relevant to us. And again, I'll walk through some tips for doing that as well. Okay, so decision 1, so a bit more on this, why MITRE? So as you see, it's got an extremely broad range of different techniques. And in my view, it can be applied across the technology stack. So not only at your infrastructure level, but also at the application level. So it gives you a nice sort of depth and breadth of different techniques. It talks about real world actors and techniques are real attacks that have actually happened in the wild. So when you're trying to talk to your business about what your SOC does and how you work, it can be really helpful if you're using real techniques and real actors to kind of give weight to what you're doing, weight and credibility. So the one other threat model that I mentioned here, there are many, is Stride. So the reason, just to give a comparison, the reason we didn't pick Stride is it's very web application focused, and I wanted something that would work across the stack and not just for one specific type of application. Okay, so decision 2, I said we need to pick the systems that we care most about. So as I said before, this is about narrowing it down, making sure you're just starting with one system just to get you going. So most people will know this already, but pick the one that contains your most sensitive data, pick the ones that contain your personal data, which is the system that if we lost it, you'd be really stuffed, like your business will go down or you lose all your customers or whatever it is. So try and narrow it down to just one. If you've got a few, then pick your favorite one, pick the most interesting one. Okay, so just as a bit of example, a bit of a dummy noddy thing. So I've just decided, okay, this is our most important system, and all this picture shows you is a really, really basic serverless web application. So just quickly on here, we've got a user store. So this contains the list of all the users and all the passwords and emails that can be used to connect to your website. We've got a backend database that contains all your data. And then we've got some code, things that store your code and run your code on the right-hand side, that's sort of the back end of your database, of your website, sorry. So that's our most important system. Just pretend that for a minute. So just to hammer that home, why is that our most important system? It's got user credentials in it that we need to protect. Emails, passwords. If you're concerned about GDPR, then this is absolutely necessary to protect that information. We've got our static web content, so we don't want attackers getting hold of those web pages and messing around with them. We've got our actual code. We definitely don't want that to get lost. And we've got, critically, the actual application data in the database. So that's just to show you why is that our most important system. Okay, so decision 3. So now we need to decide, okay, we've got that massive MITRE ATT&CK matrix, which is hundreds of different techniques. We can't look at all of those. So we need to pick the ones that are the most important. So first of all, we need to take a look at that serverless web application. And part of the analysis I did on my dissertation was to pick the techniques that could actually be done on that website. So if you look in the matrix, there's lots of things that aren't relevant to a serverless architecture. So for example, you can't run a sudo command because there's no server to run it on. So all these ones in white often apply to actually if you've got an EC2 running in the background. Because we've got serverless, they don't apply. So take one on the right-hand side, we've got defacement. So that could definitely happen on your serverless web app. They could still get access to that, to your web application code or the web pages, and change it to display a message that you definitely don't want on the front of your website. So you've now decided, okay, well, these ones are actually relevant, but which ones do we actually care about? So you've still got quite a lot of orange boxes on there. It's still too many, so we still need to narrow that down. So just a couple of suggestions here to pick the ones. So try and use your incident response data. So your security operations center should already have that information. Pick the attacks that happen to you every day or happen all the time or happen before, the ones that your business might care about the most. You might see defacement or data destruction more often than some of the other ones. And then a second one is you could take your threat intelligence reports and then prioritize on the intelligence about attacks that are actually happening. And again, that comes back to your credibility. If you pick the ones that are actually happening and you've got real threat intelligence about those, then definitely want to prioritize those ones. Okay, so now we've made our 3 decisions. So now we've now got maybe 2 or 3 different techniques that we really care about, and we've got an architecture to apply it to. So if so just to chuck up this, so how do we actually detect these now? So this is the list of AWS native services that I looked at in my dissertation. I'm definitely not going to go through all of these in this presentation. It's just too many. I'm going to go through a few of them just to kind of show the approach and show how it works. So I'm going to go through one example. So this is a technique in the matrix called initial access with valid accounts. So this is all about how does an attacker gain that initial foothold on your environment using an account that is valid under normal circumstances. So they've compromised one of these accounts that's normally used every day, and they're trying to use it for malicious activity. So, so first of all, we need to identify what are these valid accounts on this sort of dummy serverless architecture. So we've got 4 different types of valid accounts on this particular architecture. We've got infrastructure and admin accounts. So this would be things like your root account to your AWS environment, your IAM users, that could be either console access or through the API, and you've got your IAM roles. And then you've also got your end user accounts. So these are your Cognito users. These are your actual users that are using your web application, logging in, looking at data, etc. Okay, so now we've actually got some valid accounts, but how do we know that these are being used maliciously, not by someone that we intend? So again, there's probably a million different ways that you could determine if an account is being used maliciously. I've picked 3 just to demonstrate the process and the approach. So the 3 I've chosen, I'm definitely open to suggestions on more that you think we could add in here. So the root account logging into the AWS console. So best practice says that root account, which is sort of your God account on your entire environment, if you've got that account, you can change anything, should never be used. So it should be used hardly ever. So and definitely an indicator that that account has been compromised is if it's being used at all. So we want to try and detect if it's being used. The second one would be someone, so I picked an IAM user, could be anyone, logging in at an unusual time. So let's say your IAM user is used to make changes to the infrastructure during the day. So working hours might be, 9 to 5 during the day. If you see activity on that IAM account between the hours of 12 a.m. and 5 in the morning, then there's definitely something dodgy going on there. And then finally, the third example, so you might want to look at an IAM user trying to access things they don't normally access. So if you're making changes to infrastructure, you might only expect them to see them, I don't know, maybe changing the code in the S3 bucket. You wouldn't expect to see them trying to create new users, for example. So you might want to look at that. So those are the 3 compromised things I've chosen to look at for this example. Okay, so now how do I actually detect these indicators? So I'm going to walk through these 4 tools, CloudTrail, Athena, GuardDuty, and Amazon Macy, to show how you could use these tools to very quickly set up and start to detect those compromises. So the first one is CloudTrail. So for that, most people probably know what CloudTrail is. It's just a logging service. So any service you set up in AWS has this facility of logging any API interactions with that service. So those green lines just represent the logs coming out of each of those services. So hopefully you can see that, and all you need to really do there is focus in on the orange items. So what I just wanted to demonstrate here is in those CloudTrail logs is the information you need to detect that a root account has logged in. So the orange items there say, okay, we've got a user identity of root, and we've got an event type and an event name, console login or AWS console login. So it's really clear from the logs that a root account has tried to log in. So you know that has definitely happened. Okay, the second one was we're trying to look at someone logging in at an unusual time. So again, the orange items clearly show the user, Rebecca in this instance, and the time they logged in. So obviously this is just information. There's no intelligence behind this. So we are going to need another tool to say, okay, well, what's an unusual time? Show me the CloudTrail logs of someone logging in between the hours of 12 and 5 a.m. So I will come on to show you how you can overlay Athena on top of this to work that out. So finally, we said we wanted to detect unusual activity. So similarly, the CloudTrail log will tell you the user and the activity that has taken. So in this example, we've got username Rebecca, and we've got the event name is this time. So Rebecca has tried to create a user called Hacker. So again, the CloudTrail log is just telling you what's happened. You do need to overlay some intelligence to say, well, what is unusual activity? Like, how do I know that that's okay or not okay? Okay, so we've now got our raw data in CloudTrail. So now we actually need to put overlay some intelligence over the top of it. So this diagram shows how we kind of string these things together. So on the left-hand side is a diagram of the services that you need to do this. I'll just talk through these now. So the first one is CloudWatch. So what you can do with CloudWatch is set up a schedule and to say, please run every 5 minutes and trigger this thing called a Lambda function. That Lambda function just contains some code with a SQL query that you can run across your CloudTrail logs. So Athena, which is on the right-hand side of that diagram, is your sort of database. And what you can do is pump all those CloudTrail logs into Athena, and then you can run some simple queries across that data. So you could actually just enable the Athena service manually and then run the SQL queries yourself manually. But probably what you want is a bit of an automated action, and you want an alert on the back of it. So you could just do this with Athena alone, but just to make this a bit more useful for your SOC, so they don't have to continuously manually log in and check these things, you could have the CloudWatch alert run every 5 minutes, get the Lambda function to run the query for you automatically. It will go to Athena for you, run the SQL query. It will send a response back to you. So if, for example, you're taking the send me all the CloudTrail logs that have activity between 12 and 5 a.m., if that response comes back empty, you know you don't have anything. If it comes back with data, then what you can do is say, okay, well, if I receive data back here, then please trigger an SNS response, which will send an email or an alert to a support phone or a Slack channel or whatever you choose to put on the right-hand side of that diagram. Yeah, I think that's all I have to say on that one. So there's some other tools, and this is the thing with this, there's a million different ways that you can detect these attacks, and what this approach is getting hands dirty with all those tools and figuring out which ones work for you. So this is just another tool. So GuardDuty, for those that don't know, it's a native AWS tool. It ingests a huge amount of logging information, your DNS logs, your network logs, or your VPC flow logs, and your CloudTrail logs. And it's just a tool that allows continuous monitoring for malicious activity. So in effect, it's doing a lot of this intelligence for you. So in the previous example, you had to sort of set all these things up manually. But with this one, it just does it for you. So this screenshot shows you we've got root credential usage. So very clearly, it's taken those CloudTrail logs already, and it's just telling you, look, someone's logged in with that root account. So your security team can log in, look at this, and say, okay, that should not be happening, and they can follow it up quite quickly. And then, so another tool, just to kind of finish this off, that I looked at was Amazon Macie. So this tool it uses machine learning to protect sensitive data, and it also monitors data access activity and picks out the anomalies for you. So hopefully you can see that graph, but effectively what that is showing you is we've got a table of different activity in our AWS account. So on the right-hand side here are all the activities. We've got create user, put some data in a database, and it's sort of calling that out for you. So that's useful in itself. You can sort of see what kind of activity is happening on the account and pick out things that look unusual. But even more useful is it will tell you what users have done what activities. So you can see that Rebecca has created a user, or Rebecca has done this on CloudTrail. And so then you can start to map together, well, that Rebecca shouldn't be doing that. That should not be happening. And you can really easily see which activity has been done by who. Cool, so that's unusual activity. Yeah, so why bother? Why bother with this approach? What's the point? You might think, well, we already do it this way, so why would I bother doing it the way you're saying? So I guess what I think with this is it's a really easy way of just getting some alerting set up without waiting for that full monitoring design. So when you're moving, if you want to start using AWS or start building a proper enterprise environment in there, then it can take a really long time to come up with your monitoring architecture. And often your security operations center is told at the last minute, can you just monitor this thing for us, please? And so you might just really need to get something quick and dirty set up to start monitoring for something on your most critical systems with the most likely attacks. The other really good thing about it was, so our developers were already using these tools, already quite familiar with them. And so it's just a really nice way of building relationships between your security operations center and your development team, so that you can work much closer together. You can learn about, well, what's actually likely to look unusual on that particular project. And it just works for a better working environment. It's relatively low cost and quick to set up. So there might be scenarios where you've got applications that don't need a full monitoring solution. So you don't need to attach it to a full scene or send it into Splunk, for example. You might just say to them, look, we know that these tools detect these things. Can you just set these up for us? And then you might even say, well, can the development team run that for us? And then at least you've got some security on that application without having to plug it into your centralized security incident events management system. And then also, so I've chosen to do this on AWS, but you could use this on any environment. So you could use this on Azure, you could use it on an on-premise environment. Obviously, you'd need to use the tools that are relevant to the environment you're using, but you could use the whole prioritization thing, breaking it down on any environment. Some challenges with this. So I've just shown you 4 tools. There are a million. There are so many of these things. And to really get any benefit from it, you do need to have a really good innovation culture in your team. So if you want to do something like this, then I definitely recommend investing in giving your team time to spend a little bit, I don't know, half a day, a week, logging in, looking at a new tool, understanding it, reporting back on how you think you could use it in your team, just to help, bring that knowledge in. I would say you do need to invest in quite a detailed understanding of AWS if that's the environment that you're looking at. So again, to understand all the different tools, you do need to spend the time. If you've got a good innovation culture of people that want to learn, that want to log on and get hands-on with the tools and set them up and learn how they work, then you'll be absolutely fine. It won't take long for people to come up to speed. And then, so this might be good enough for you, depending on the system and depending on your sort of security posture, but it doesn't work for everything. So you probably still need a scene in certain circumstances. You might be thinking, how am I going to bring all these logs together? I need to know when something's fired in Athena and something's fired in guard duty. You're going to need some tool to bring all that together. So this is definitely not the full solution. I think that's it. That's me done, Dean. I don't know if you want to come back to facilitate the Q&A. Hello.
Steve's adding me back in. Awesome. So there's been a couple of questions in conversation going on the chat, which you probably haven't seen. So
no.
I'm going to hit you with those now. So one question we had, or more of a conversation that a couple of people were talking about, was I was asking people if they'd used the MITRE or Stride frameworks at work, and a bit of conversation about that and around. Somebody said, Omar said that he or she, whoever that is, wrote, depending on product team and client preference, they picked like MITRE or Stride. Right. And then also a comment from Woody Woodward, obviously the best Twitch name, I think, of the night. There should be points for the quiz for that. And saying that they've dabbled with Stride and MITRE, but prefer MITRE as Stride felt quite long to complete. So I guess from that, is there a question around, have you analysed like any more of these frameworks? Have you got any comments on like why you picked MITRE basically?
Yeah, so I've worked with both. I've worked with Stride and I've worked with MITRE. I definitely agree that Stride can take a really long time. I think if you're trying to bring teams together, so if you're trying to bring security and project managers and developers all together, you're trying to get them to actually work together, then Stride is really good for that. But you do need to be patient with it because there's a lot of cards to get through and a lot of game playing to do. And I think MITRE is, again, I suppose I said a little bit there, and again, Stride is great if you've got sort of an agile web application team, because a lot of the cards and the sort of attacks in there are geared towards how you hack a web app, and the MITRE is definitely better if you want to do an infrastructure type project and you want to focus just on your security team.
Awesome. Yeah, I'm learning a lot. I'd heard of these by name and had a little look, but I've never used any of them. So I'm learning loads here. So another question from Jeff was around guard duty. He was saying, do you have to create a use case to find like what it is you're looking for, you can probably see that now on the screen. If it ingests all of these logs, do you have to kind of configure it to present one of those techniques like root account usage, or is there predefined rules in guard duty to do that for you?
No, they're all predefined. Like it's just a can. It's a can of things already done for you. So there's a massive list of things that it looks for, and you just turn the tool on, and it will just tell you that that malicious activity is happening without you having to do anything at all. You can't customize it as far as I know. So you can't add in your own rules. You just have to take what they give you, which is actually a really broad set. A lot of it is like so if you've got EC2s running, it's things like SSH, people logging in with SSH, or like malicious IPs trying to connect onto your server. So there's a huge amount of stuff that's already kind of pre-canned for you in there.
Nice. So are they specifically mapped to the MITRE framework, or are they just in there as general cloud security techniques?
In there is general cloud security, but I have, as part of my project, I have mapped them. So if you're interested in the mapping, then I can probably send that across to people.
That would be really interesting. Yeah, maybe we can share that after and we can get that out to people if they're interested. Let us know in the chat if you're interested in that, and we can surely get it to you. Okay, so a couple more questions. I won't kill you with a million questions.
All right.
One here from Gilly Willy, which says quite a few of the MITRE attack scenarios require correlation of events across different logs. Like, how much of this do you think you can get away with, or not get away with? How much can you get without or before looking at like a full-fledged SIEM solution?
Yeah, so I think when you've got if you've got a serverless architecture, then I think you can get away with quite a lot without using a SIEM. But if you've got EC2s and you've got containers and you've got kind of stuff that's not serverless, then I totally agree with you. I think you can probably, it is a quick and dirty thing. Like, I'm going to throw a figure out there. It's probably completely random. Like 50% of it, I think you could probably do with native tools, and 50% you're going to need some sort of tool to correlate those logs.
Nice. What else have we got here? We've got, Jeff's got another question. Jeff's getting all the limelight. I'm just going in order, by the way. Can you hook these logs into a traditional SIEM? Like, are there connectors for those? How do you pull these AWS logs out and get them into the SIEM?
So I think it depends on what SIEM you're using. So I'm not an expert on this, but I think Splunk does have some connectors for AWS. So if you're looking to get CloudTrail logs in, then that's pretty easy. So things like EC2s, if you have to install an agent on those, and then you can pump those into CloudWatch logs, and then you can publish that to your SIEM from there. So there are connectors, but I'm not an expert on that, so I don't really know. Nice.
Azure Sentinel SIEM, by the way, has a connector for AWS CloudTrail, by the way, just putting it out there.
Sales pitch.
And also down here, or down there, Sumo Logic probably have, I imagine they have a connector as well for that. I believe they do. Nice. Did you look into or consider using CloudWatch metric filters as opposed to Athena?
So I looked at CloudWatch metrics, but not as an alternative to Athena. I'll be interested in understanding what kind of attack you're looking at there and what you're thinking.
Well, let us know in the chat what filters, CloudWatch metric filters, you think you might be able to achieve, because that could be cool if we could kind of get some feedback back as well, and kind of look at this and see if there's other ways it can be done. I think, like Rebecca said, there's so many tools in the cloud, right? We could bolt so many of these things together to do the bunch of things, right?
Yeah, definitely.
Nice. I think that's it. Let me just see. I did make some notes as I was going along. I had a question actually that I thought of while you were speaking, which was, are the MITRE attack techniques grouped anywhere? When you mentioned the techniques, you said like some of these techniques wouldn't be relevant to this serverless app, for example, because it's like, I don't know, sudo to root or whatever. Do you know if there's anywhere there's like a mapping, like the MITRE attack techniques for web apps and MITRE attack for data ingestion or whatever, or serverless or whatever? Does that exist? Or
no. So I had to do a full mapping of these are relevant to serverless architecture, these are relevant to a non-serverless web app. Like, no, that would be amazing if that was a thing, but I haven't seen it anywhere.
Sounds like an opportunity for a open source project or something on GitHub.
Yeah, maybe I'll start there. I'll think about it.
Nice. Well, yeah, awesome presentation. I learned a lot, definitely. Thank you so much for coming along. And by the way, I don't know if I mentioned at the beginning, Rebecca won the quiz last time, so we'll see if how Rebecca fares today later on in the session. We will. With that, thanks so much. We're going to get our next speaker up now, Mark. So thank you so much, Rebecca, for coming on. I really enjoyed that session.